Hey stats class, I want to show you how you can use your TI calculator to help you with confidence interval that you have to create in 7.3 that are chi-square distributions. These are no longer symmetric bell-shaped curves. Remember, the chi-squared from your notes has a right skew, and so we're not going to add and subtract something here. It's a completely different procedure. All right, one thing that is in common though with the T distribution is the degrees of freedom here is still one less than your sample size. So I got 22 for my sample size. That means degrees of freedom is 21. So that doesn't change. Now my chi-squared left. This is a bizarre procedure to get this critical number. This is a critical value in the chi-square distribution. So we typically get critical values from like the distribution menu and an inverse. Like inverse normal gave us critical z's. Inverse t gave us critical t's. Well, there's chi-square, but there's no inverse chi-square on this calculator. So what I need to do is use something called the solver. So I'm going to press the math button and just press the up arrow, and it'll go to the solver right here. Press it up too many times. So this is what the equation solver looks like if you've never used it before. If you do have something in here, you may have to press up and clear out any equation that you have in here. You have to set the equations equal to 0. So what we're trying to do is, if I was using the that chi-square CDF feature in the TI, it takes in, it's very similar to the normal CDF. It takes in a lower number, it takes in an upper number, and it takes in the degrees of freedom, and it tells you in that chi-square distribution what percent falls in here. Okay, now what we want to fall in here, what we want this equal to, is going to come from this confidence level. So the chi-square distribution is like again, it's a right skewed distribution. And with 98% confidence, there is 98% in the middle somewhere in this distribution. Again, it's not symmetric, but in the interior, there's 98%. And that leaves 1% in this lower tail and 1% in this upper tail. Now the chi-square distribution does start at 0, but it does not have a hard upper bound. So what we want, again, chi-square distribution, just like or chi-square CDF, just like normal CDF, is going to give me area. All right, so that's what comes out of chi-square CDF is area. So we want this to be equal to 0.01. We want it to be equal to 1%. And we know the lower number is 0 because that is always the lower number in a chi-square distribution. So the left tail, if we're trying to find area there, is always going to have 0 there. We don't know the upper number. We're going to call that x. We don't know this. We don't know what this number is. But we know the degrees of freedom, again, is 1 less than this. So the degrees of freedom is 21. And so that's the equation we're solving. It's just that the equation solver has to have a 0 there. So we're going to move this 0.1 over. I'm going to subtract 0.1 from both sides. Technically, I did the 0.01 first and then subtract the chi-square CDF. But that's the idea here. That's what I'm doing with this procedure here. So my area, again, is going to be, this is just the 98% taken from 1. So 1 minus 0.98 is 0.02. Divide that in half. I get a 0.01. And I'm going to subtract the chi-square CDF. So that's going to be second bars. Scroll down to chi-square CDF, not PDF. All right, my lower number is 0. My upper number is x. My degrees of freedom is 21. All right, I'm going to paste all that in there. Notice it's 0.01 minus all that. All right, now I'm going to go down here and hit, it wants me to guess this x. If it's blank, you need to come up with a guess. So I'm just going to arbitrarily guess 20. It just has to be something bigger than 0. All right, now instead of hitting enter, you actually press alpha enter. If you look up there, it says solve. Alpha enter. It'll take it a second because it's doing a lot of different calculations to estimate this. So there's the number that it's given me. So I want to round this to 3 decimal places. So that's going to be 8.897. Now I'm going to repeat this, but now I'm doing the chi-square right. So in that picture that I drew, so I'm just drawing kind of a right skewed distribution. So there was the 0. This number we found to be 8.897. Now this is not symmetric. So it's not going to be like a negative 8.897. It's just some number in this right tail, where from that number on, again, that's going to be my x this time, and that number on, the area is also 0.01. So we found that 8.897 number is the number needed in the left tail to make the area be 0.01. The right tail, though, doesn't end. It just keeps on going forever. So just like we've seen in previous videos, I can use a 9999 in that case. So this is going to be my lower number, x, and my upper number is going to be, just a bunch of nines. Just if you don't know if you've got enough nines, just put in more nines. All right, so I'm going to press up. It goes back to the previous equation solver. And I'm just going to scroll here. Instead of 0, x, I'm going to do x, comma, a bunch of nines, 99999, and then I have 21 degrees of freedom. All right, close that off. I'm going to press down. It wants my guess. All right, but it's just giving me the same number that it came up with before. It's going to be to the right of that. So again, I'm just going to put in 20 and let it go from there. So alpha. So once it's done thinking, it's still spinning over there on the top right corner. Once it's done thinking, it gives me this number, 38.932. All right, to 3 decimal places. Okay, and you're thinking, okay, I think I can do that. I got that. Well, that's not even it. That's just the critical numbers for this. To get the confidence interval, we're going to use those critical numbers, but we still have a calculation to do. So the last calculation we need, and you can get this from the view and example of the formula, but the last calculation we need is we're going to take the square root. We're going to take our degrees of freedom. We're going to multiply by this standard deviation they give us, but instead of the standard deviation, we actually use variance, which is that number squared. And then we're going to divide by, first, the R1, right? The bigger number. When you divide by a bigger number, you get a smaller fraction. So this is actually going to be the left end of the distribution. All right, that's going to be that first box. And then we're going to repeat it, but we're going to replace the 38 with the 8.897 the second time. And that's going to be our right number, our second number in the box. All right, so I'm going to hit second mode. Go back to the main screen. This is the square root of, in the numerator again, it's the degrees of freedom. So 22, so that means 21 times s squared. So that's 0.29 squared. All right, and then the first time I'm going to divide by the 38.932, the R1. There's my lower number, 0.21 to 2 places. All right, and then the second time, all I have to do here is hit second enter. That'll bring back the last thing I just did, and then I just change this lower number, that number, the chi-squared L. So 8.897. And so there is my upper estimation, the 0.45 for the upper one. All right, and so that's the procedure that you have to do to get these with the TI calculators. Because there is not an inverse chi-square button, we can create one with that solver button.